Hi, this is Paul again. Now I'm going to show you another video, and this one's called No Chaos 4 for ADNA. In my last video I showed how the golden rectangles could show the 369 arrangement. Very simple. So we can take another look at it, and you can see that the yellow and cyan rectangles, which are golden ratio to each other, rotate at 120 degrees perfectly. I showed in my earlier videos on ADNA that the ADNA was based around the phi YUCATAN. Now you can see the 120 degree rotation is based around that purple YUCATAN that I show. Now to form the ADNA rung, I used the Z configuration that I used on the bDNA. So now that I've discovered how these golden ratio rectangles go, I'm having second thoughts, because the golden ratio rectangles is beginning to look very much like the zDNA rectangle with two cross diagonals. Now the zDNA actually was a lot smoother for the rectangles and the pyramids of the size 3 icosa to make the rungs. So let's make the ADNA setup similar to the zDNA setup. So I'll try to make it very simple so that you can understand. So I'm going to hide everything except the cyan and yellow rectangles to start. Now you can see that I've got a size 1 icosahedron in the center and the dodeca around it. I have shown in my earlier videos that the icosahedron can be arranged along the vectors, so we're going to make copies along the center vector, the vertical vector. First copy will be risen up √3, which is 173.205, and now we'll move a second copy down √3, the same. Okay, we'll hide the dodeca and you can see it better rotating around a bit. And now you can see that it's very similar to the zDNA, but we've got a lot of possibilities here. There seems to be different types of rungs that we can get out of this. Now let's look at the first type, which is like a V. And I can make 2 rungs out of this with strings of icosahedrons, because I made rungs out of the zDNA, which was very similar. But there is a difference between the two. In my last videos I showed that the zDNA was sloping and it was golden ratio to the vertical axis. Now you can see that these rectangles are horizontal to the vertical axis, and you can see this as I rotate copies 120 degrees to make a 3 stack. I'll hide the rectangles and do this with just the rungs. As you can see, I'm just using a 44.6 degree section of the curve. So it's easy to make a longer curve out of the 3 sections. I'm also going to hide the center icosahedron, because I think the ones shown are the essential. So now I'm showing the first example of an ADNA setup. But some illustrations show that the ADNA rungs are at a bit of an angle. So let's return to the rectangles again and take another look. Okay, I'm showing the yellow and cyan rectangles rotating again. And you can see that the V vector passes through the center of the faces of the icosahedrons. Okay, look what happens when I turn the V rungs to straight rungs. Now you can see that the white curve has moved up to a higher position. I'll give it a little turn around and then I'll bring it back to the original position. So now we can make copies of this assembly. So we'll rise each copy up √3 twice, and each copy must be given an 120 degree turn. Okay, let's repeat this with just the rungs, you can see it better. Now the curved portions that you were looking at are from the wider gap of the 2 golden ratio rectangles. So these curves should have an angle of 75.4 degrees. So the gaps must be 44.6 degrees, making up 120 degrees. So now we can join them up. Okay, let's take a look at it turning around. And now we can see this new variation of the dual helix. I'm going to hide the center icosahedron because I wasn't using it for the rung geometry. Actually, we're going to have two size 3 icosahs opposite each other. Let's take a look. So I've put together, as you see in front, a typical A-type DNA set of rungs. I've showed in my earlier videos that the pentagon and hexagon molecular arrangement can come out of this geometry. Now in this arrangement in front, the rungs are straight. But earlier on, I showed that it could be a V-shaped also. And a couple of years ago, I put out a video showing ape-type DNA coming out of a Z configuration. I started putting a bit of thought into this, and I was thinking which of these are correct. They might be all correct. So we'll go back to the Yucatan rungs and I'll show you why. Let's go back to the dodecahedron again and show the yellow rectangle. And now I'll show you the first aDNA rung, the straight one. And now I'm going to hide everything except the essential vectors. Now if you notice, the top Yucatan is 180 degrees difference between the bottom Yucatan. I'm going to change the Yucatan color on the top to green, and then I'm going to zoom out a bit. Now I'm going to make copies of this assembly and move the copies √3 along the red and yellow center vertical axis. So now I'm going to hide the string of dodecas. Now you can see when we make a string, the top and the bottom Yucatans line up together. We'll just hang on to this set of 3. And now look, we can transform into our first type of vector, the long one. And you can see it in the Yucatans, or you can see it in the dodeca, or you can see it in the rectangle. Okay, so let's go back to the string of 3 again, because I want to go back and show you the zigzag type that I showed in my earlier videos a couple of years ago. Now you can see that it'll transform into the zigzag type. Now you can see that the Yucatans, the purple and green Yucatans, are closer together. They will be √3. So now it shows that we have 2 different slopes. We can go from 1 √3 to 2 √3s. But before we go there, I'd better show you that we need 2 dodecas for this assembly. Now we've gone from 2 to 1. The only one left is a horizontal one, the 0. Now on this one, I jumped to conclusions. I thought it would go from the purple Yucatan to the green one on the same level. But I was wrong. It goes from the purple to the purple. And to do this, we have to give it a different vector. I'll zoom in and take a closer look at this. And now you can see that this V has a different vector. And you can see that it's got the green and yellow vector also. Now you can see that the geometry of these 2 vectors are perfect. Now this geometry is very similar to the Z geometry that I showed in earlier videos. I would say that it's something important for researchers to look into. But by now I'm beginning to think that intellectuals just don't have time to work on 3D geometry. Anyways, for those that like to look at new stuff, I got something else to show you. But I was going to show it in this video, but I think I'll start another video on this one. I think you get the picture with this video that you can get 3 types of aDNA rung. This is Paul saying thank you very much for looking at this video.